All right, today we are finishing up dealing with adding and subtracting rational expressions with Chapter 8, Section 2. When you guys are dealing with fractions, you always have to have like denominators, people. So we're going to look for the least common multiple between a 5n, a 4, and a 10 times n. So let's break it down into its factors. This is a 5 times an n. This is a 2 times a 2, also known as 2 squared. This is a 2 times a 5 times an n. So what we have to do is scan these and look for the least common multiple between a 5, an n, a 2 squared, a 2, a 5, and an n. That's a lot. So let's think about this. We definitely need a 5, don't we? All right, so we'll put a 5 times. This one has a 2 times a 2. This one just has a 2. So we actually need what's called a 2 squared. And then we also need an n. So our least common multiple is 20 times n. All right? So in a quick little review, let's do a quick review of how to find the least common multiple. So let's say I have an a and an a. What's the least common multiple between a and an a? A, just a. Okay, what's the least common multiple between an a and an a squared? A squared. Okay, what's the least common multiple between an a and an a squared b?
A squared.
A squared b. Okay, here we go. What would be the least common multiple between a to the 4th and a squared b? That would be a to the 4th, and you'd have to have a b. All right? What if I change and go, you know what? What's the least common multiple between a and an a squared bc? A squared bc. What if I change this and say, ooh, that's a to the 5th? Then it's going to be a to the 5th bc. Okay? So what you got to look for is look for the greatest what? The greatest exponent for each individual monomial. What's the greatest exponent for the 2? 2 squared. That's why I had to choose a 2 squared. What's the greatest for a 5 to the 1st? It's just 5 to the 1st. And for n to the 1st, it's just n to the 1st. All right. So now that we've gotten that taken care of, if that was confusing, you might want to go back a couple of videos and start from the beginning. Now, right now I have 1 over 5n minus 3 over 4 plus 7 over 10n. So what I'm going to do right here is I'm going to have some parentheses right here. We want every single one of these denominators to become a 20n. That's what we want, every single one of these denominators. So right now, I'm going to put something over 20n minus something over 20n plus something over 20n. What we have to figure out is what numbers would have to go in the numerators eventually. So right now, let's look at this. This has a 5n, but I want it to become 20n. So what would I have to multiply the numerator and the denominator by in order to make that happen? 4 is 20. A 4 and a 4. So we have 4 times 5n is 20n. 4 times 1 is 4. You put 4 over 20n. Now, please don't reduce it back to where you started because then you'll have to do it all over. Now, we've got a 4 here. I don't want it to be a 4. I want it to be a what? 20n. So what do I have to multiply the top and the bottom by to get me to a 20n? 5n. So put a 5n and a 5n. And I have a minus, but what's 3 times 5n? 15n. That's 10n. I want it to be 20n. So what do I got to multiply the top and the bottom by here? 2. Nope, just 2. Because 2 times 10n is 20n, and 2 times 7 is 14. Now I'm breathing a little bit easier, because now, look at all the denominators. They're all the same. All right, now we simply need to take the 4, the 15n, and the 14 and combine them together. The only numbers that can technically be combined is the 4 and the 14, which gets me a total of 18. That says minus a 15n, so we're going to put minus a 15n all over the common denominator, which was our least common multiple, of a 20n. And this is your final answer. The reason why this is your final answer is there is no factor that's common to an 18, a 15, and a 20. A 2, a 4, and a 5 go into 20. A 2, 3, 6, 9 go into 18. And a 3 and 5 go into 15. So you can actually, by the way, you could factor out a 3 if you wanted to. Okay? You could factor out a 3, but notice, does 3 go into 20? So it would still stay like that. You wouldn't be able. So technically, I'm going to put 4. Technically, you might see this as a multiple choice answer if they factored out the 3 out of both of those. Okay? Now we're moving on to problem number. No, we already did that. Problem 18. Now, what I would hope every single person in the world would know is when they saw a difference of squares, they would know how to factor. Does anybody want to, they're on YouTube right now, want to take the courage to be brave and factor this formula? What's that going to be? Raise your hand. Go ahead, Blue.
A and wait, A and the minus 3.
Yep.
And A plus.
That's correct. A minus 3, A plus 3, or A plus 3 and A minus 3. That's the difference of squares. Now, everybody, right above this, I'm going to write least common multiple for this problem will actually be A minus 3 and A plus 3. Good job being brave. Right now, I really want to say, attaboy, whatever. All right? So right now, let's think about we have a 2A over and A minus 3. This guy needs something. I'm not going to tell you what it is yet. Minus 2A over A plus 3 plus the only thing that doesn't have to be changed is the very, very last rational expression. Because this denominator has everything that it needs. It has the A minus 3 and it has the A plus 3. So this guy doesn't need anything. All right, now let's look at this denominator right here. This denominator right now is an A minus 3. But I want it to be A minus 3 and A multiplied by A plus 3. So what does this guy need that it doesn't have? So put A plus 3 here. And put A plus 3 here. Now this denominator is by itself the binomial A plus 3. So what does it need to be multiplied by? A minus 3. So put A minus 3 and A minus 3. Now sometimes students will pause. Like they get to this point like, okay, great. Now what do I do? Now what you got to do is you got to take the 2A and multiply it to the A. And then take the 2A and multiply it to the 3. So we're going to bomb this into it, distribute it into both monomials. So what is 2A times A? That's right. And what's 2A times 3? Very good. And put this over, everybody. Put this over. A plus 3. A minus 3. Minus. Just so you know, it's still going to be A plus 3 and A minus 3, and this will still be, oh, that's a horrible A plus 3. Let's just pretend that didn't. This one is easy, it just stays 36. Now we have to multiply the 2A times the A and 2A times the negative 3. What's 2A? 2A times an A. That's 2A squared. And what's 2A times negative 3? Negative 6A. Now, if you guys would please put this in parentheses, okay? Because I did not multiply the negative that time. I didn't multiply the negative. I just multiplied the 2a times both of those monomials together in the final. All right, so we're almost done with this problem, everybody. Almost done. What I want us to do right now is I need you guys to take this negative and multiply it into the 2a squared and into the negative 6a. Okay? So right now, just so you guys know, our common denominator is still a plus 3 and a minus 3. Okay? I'm just going to write, we have a 2a squared plus the 6a, that's from this. Then I have a minus 2a squared. And then a negative times a negative makes a positive 6a. And then at the very end, I'm just going to stick the 36. Right there. Now, we have some like terms that we can combine. So this guy can be combined with this guy. This, let me change color. This 6a can be combined with this 6a. And then we just got the constant 36 right there at the end. So, if you have 2a squared and you take away 2a squared, how many a squareds do you have now? 0a squared. No, you don't have 1. You have 0. Okay. If you have 6a and you add 6a, how many a's do you have? 12 a's. Are you just saying random numbers out there? But people might get confused. Then we have plus 36 at the end. Now, here's what you have, everybody. You have 12a plus 36 all over a plus 3 and a minus 3. This is where you have to be really discerning, because some students will just do this. I am done, 100% finished. And other students will go, wait a second, can I go further? Now, we can go further. What can we do to the 12a plus 36? There is a special number that I can factor out of 12 and a 36. 12. I can factor out a 12 out of both of those numbers. And this is the most important part. This helps you kind of go to the next level. All right? Because 12 times what is 12a? 12 times a. And 12 times what is 36? Now look really carefully, because now you should realize the reason we had to factor out the 12 is because now the a plus 3's cancel each other out. Because any number divided by itself is 1. Our final simplified answer is 12 over, bless you. It's not 12 over, bless you. It's okay. It's 12 over a minus 3. Understand, in a multiple choice test, this will probably be one of the answer choices. And when it asks you which answer is your best answer, that would not be your best answer. This would be your most simplified answer. Simplified, not simplified. Better spell it.
I don't know.
Simplified. There we go. All right. Simplified means there's no other factors that you can factor out that you can possibly reduce. This is as good as it gets. That's going to be the last problem we're going to be able to do. Everybody say goodbye.
Bye.